Hey, dude, man, we forgot to light this thing up. So anyway, here's what we can do. We can talk about that first example. If you read through it, that's going to be pretty straightforward. It's going to be without pain. But then doing this work here, this I can explain really fast. So what we did is we took this spreadsheet that I shared with you. And in order to do the cumulative frequency, we need to begin with, this is simply that value. And then what goes into this cell will be this 3 plus that 0. And then the 18 plus whatever. These two add up to become this. These two add up to become that. So the way we're going to put this in here, oops, is we're going to say that this is equal to this cell B3 plus C2. Then come back and drag and copy it down. See, you can just go on pause and stop it and then figure it out and come back. Okay, and then to do the relative frequency, that's simply going to be the frequency divided by the sum. The way we do this is we're going to say that that is equal to this cell frequency divided by, we need to lock into that cell and not let it change when we drag down. So we do that as $C $12. We're going to copy and drag that down. But these are all decimal numbers, so we need to change them to percents. So you can either come up in here and find where the percent is for formatting, or is it?
The dollar sign up there.
Or we can just put in parentheses what we're adding up and multiply by 100, which is what I did. Then cumulative relative frequency, this is 0, and then again we're going to take these cells and add them. The next value added to the previous. So that's going to be this plus. And we copy, voila, 100%. Okay, there, now we're caught up again. Sorry, dude, this is what we did. If you're even watching, who knows? Dun, dun, dun. All right, so then moving on. What do they ask us to do with this, the activity? We filled in all of that, and then we need to make a graph of cumulative relative frequency to find the quartiles. So cumulative relative frequency.
Okay.
So what do you think? You know, they show doing a kind of a scatter plot, but either way, we need to graph the scores to highlight those with cumulative, scores, and then, so what I did to highlight two different columns is I dragged and highlighted the first, then I held down the control key, and I dragged and highlighted my second column. Now I have the two columns I want to graph. You guys good with doing that?
Mm-hmm.
Awesome. So then, what, we want to insert a chart?
Correct.
Chart. Well, they call it charts on here, but chart graph. So here's a line. There's a, like a scatter plot type. I think that the scatter plot might be easy to read because we're looking for quartiles. So we're looking for when does it get to, look at that, there it is. Look at those lines. Now you can see where your quartiles are. So here's a quartile, there, there, and there, a quarter of the data. So these three numbers here are your quartiles.
And wait, how do you say you found the quartiles?
So if you picture this as being a box plot, And then turn the box plot up on edge. This is your minimum down here, right? And it goes all the way to your maximum. And then if we, what do we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, don't we have 12?
Yeah,
we
and we have 11.
We have 11 data points in terms of cumulative frequency. So if we were to divide this up, 1, 2, 3, 4, 5, 6,
That's like me.
that's a median. And then we have 1, 2, 3, 1, 2, 3.
We want to go 7 because it's 6
So here's how your data is spread out. Gesundheit.
We could have estimated that.
Yeah. Something like that. You know, this down here isn't real pretty. But this allows you to look at your quartiles in terms of actual data points. I don't know if this is the best view or not. I think I had,
Why wouldn't we use the lines that the graph has to make the box plot?
Yeah, we've got.
why
Because
wouldn't
no,
you-
because then that would make an even box plot and isn't evenly distributed.
no, it's not evenly distributed, is it?
The right of one.
Yeah, a lot of your precipitation happens when, I'm sorry, this isn't precipitation. A lot of your scores are, they're real heavy right in the middle, right? 13 to 24. So if they're heavy in the 13 to 24, they're from here to here. This right here, this is the majority of your test scores. Because they're, you know, these changes are happening. These are where the areas of greatest change are. So this is a large quantity of the scores. Now, you know, you might be, I don't know. Where do they hit 25%?
Like 3, right?
Yeah, right here. Where do they hit 50%?
6.
And 75% is right here. So that all happens within these sets of scores. So this, I think I had this on my document before I gave it to you. I got rid of all the graphs. And I think that if you were to look at this, your 25% is right in here somewhere. And there's your 50%.
So you can go by the y-axis.
Yeah. So maybe we have a median there and we have a box that looks like this. And then this goes all the way back. You see what I'm doing there?
Yeah.
So this shows that there's a lot of scores squeezed into the middle, and down on the bottom it's spread out, and up on the top it's spread out. I like looking at this bar graph better than the scatter plot.
Yeah.
The scatter plot doesn't show it quite so sweet and neat. There's your cuts. I like that one better. So what else do they have us doing? Construct a box plot.
Is it about?
Did you do it on here?
No. I've always watched you do it.
How do I do this? Edit chart? Then change the column to a, I swear we could do box plots. It requires at least 5. I thought sheets could do box plots. Maybe it's just Excel. It might be Excel.
Because they really excel in that field.
Yeah, I know, ha ha ha.
You only have 5 homework problems?
Yeah, I know, but each one of them's got like A through F. It's one of those. Not really, but partially.
Oh, that's
Okay,
nice.
so let's see. If you're gonna do a box plot,
Oh,
Then-
we have charts.
then what data do we want?
I want the
What if we do a stacked bar chart? Then at least we get
I think we would use frequency if we wanted to use a box
Yeah.
plot. So you have 881 scores. So what we need to do with this is we need to divide up that 881, which we have done with this cumulative relative frequency. So your median, I don't think we can get real exact with it, because the actual 50% is within this range of 13 to 15. See, this is building up to 50%, right?
yeah.
So to find that 50th percent, once you add the 16 to 18, then you have 50%. But, yeah, so you start at 34% here, and you add from the 16 to 18 group, and you'll hit 50 and go beyond. But what are you adding? Are you adding 16s, 17s, or 18s? We don't know. So making a box plot doesn't make it, it's not a great thing to look at for analyzing the information. Simply looking at cumulative frequency is going to be the way to go. So let's leave it at that. And percentiles. I've talked with you guys in the past about what percentiles are and what they mean, but it gets brought up here. And if we look at the definition, it's kind of a tough one. Where are you? Come on. It's in a green. There it is. So the pth percentile of a set of numbers is the value in the set such that the p% of the numbers are less than or equal to that value. So if we say we have the 50th percentile, that means that 50% are less than or equal to that number. So a person tests and they're at the 75th percentile. That means they are their 75% are less than or equal to their score.
So only 25% did better.
So 25% did better, or maybe ever so slightly more because of that or less than. So it's kind of like, can you be at the 100th percentile? Well, if you're at the 100th percentile, that means you're the absolute very, very highest. And you are the only one that's there. So in these big tests like ACT and stuff, we don't have 100th percentile because there might be, well, there will be more than one person in this country that gets that high.
Interesting. Even if if they don't get higher than you, they get the exact same score.
Then you're all sitting there at the 99th percentile. Because to be at the 100th, you got to be above everybody. And that doesn't happen in big tests.
That's neat.
So, 1 through 5, huh? Or 1 through 4? Hold on, you got to wait for these guys to get out, okay? How are you doing it in the other classes? You just pile on in, or what?
They're usually gone.
They're usually gone, yeah, well, we're never gone.